Let me explain the semiconductor supply chain. Let's look at this example, iPhone. How Apple makes iPhone. Apple designs a chip called A15 or A16 or A17. They have A series chips for smartphones. They have M series chips for their MacBooks. Basically, they use A series chips for their smartphones. How they make this silicon? Apple is a US-based company. They own the design. They create the architecture for chips like A15, A16 or A17. And then they take the design through design flow. If you consider the design flow, there could be various steps. It's composed of front-end design and physical design. As part of the front-end design, we do RTL coding. We verify the RTL design through simulation, and then we synthesize it. That's how we generate the netlist. That's front-end design. And whatever the netlist we generate, basically we take the netlist through physical design. And as part of the physical design, we follow various steps: floor planning, place and route, static timing analysis, clock tree synthesis, physical verification, and then finally layout versus schematic. And that's how we generate routed netlist. So at Apple, what they do, they basically generate the routed netlist. It's called GDSII. And they outsource the chip fabrication to a company called TSMC, which is based out of Taiwan. So Apple is a fabless chip maker. But overall, you consider the company Apple, it's called as OEM, Original Equipment Manufacturer. They basically create devices like smartphones, desktops, and then they sell it directly. That's why we call them as OEM, Original Equipment Manufacturer. But the best thing about Apple is actually it creates its own chips for their devices. So they design the chip, A-series chips, and then they send the routed netlist GDSII to Taiwan. There is a company called TSMC, Taiwan Semiconductor Manufacturing Company. TSMC fabricates their chip. So the fabrication doesn't happen in the United States. You consider fabrication, it's only 10%. And Apple doesn't do any fabrication in the United States. And Taiwan is very popular for chip manufacturing. You find so many foundries there. So basically we need foundry to fabricate the chip, and we need army of technicians to run the plant. So it's pretty complex. It's very expensive. So the fabrication happens pretty much in Taiwan. And then the chip goes through assembly and testing. So there are many companies, we call them as OSATs in Malaysia. Malaysia is very popular for assembly and testing. And then the final chip will be used for the motherboard. Again, Apple designs the motherboard. The design happens. It might be PCB design. And they might also outsource the PCB work to companies in China. So China is very popular for PCB. It happens even in India. But Apple might outsource it to some companies in China. So that's how they make the motherboard. Also, China is very popular for OEM product assembly. So Apple outsources everything to companies in China. What they do is they make all the spare parts like display unit, keypad, everything, camera, and they put all the stuff together. And the primary thing, what they need is the motherboard, right? So Apple outsources the chip fabrication to Taiwan, and then TSMC makes the silicon, and then it goes through assembly and testing somewhere in Malaysia or maybe in Taiwan. And then the chip is used to make the motherboard, and then In China, basically they use the motherboard to create the final product. They also make various spare parts and then they put all the stuff together and that's how they make the product. Now, the important thing is to design the chip, A series chip, Apple buys hardware components from various companies. Let's look at the design part. To realize complex chip like A16 or A17, basically they need hundreds of IPs. We call the hardware component as IP, intellectual property in semiconductors. They need processors. They need various kinds of interface IPs. They need memory controller. So like this, Apple might buy hundreds of IPs from various companies. So when it comes to SoC design, we call these A series chips as SoCs. Whether it's A series or M series, they are all SoCs. To design this kind of complex SoC, basically they need hundreds of IPs. But what they do is actually, they buy 80% of the hardware components from the external vendors and then remaining 20% they design on their own. For example, Apple designs its own GPUs. They don't buy GPUs from any company, but they buy processor from a company called Arm. So here is the important thing. Arm is based out of UK. It's a fabless IP company. Arm doesn't sell silicon. Arm actually sells the processor as IP, intellectual property. And the other important thing is, though Arm is UK-based company, still they may have operations in various countries. For example, Arm has operations in India. They have a branch in India. And Arm India deals with mostly verification and physical design, right? Again, Arm is a UK-based company and they own the design. They deal with circuit design. They create the architecture. They create the RTL design. And then when it comes to verification and physical design, they outsource the project to Arm India. Now, you consider the chip fabrication. Let's look at this chip fabrication. To fabricate the chip, basically, the foundry needs various equipment. Countries like Netherlands is popular for supplying equipment. So there are companies like ASML. They are very popular for EUV lithography machines. ASML provides the machines needed for chip fabrication. Similarly, these foundries might buy some specialized materials and gases from countries like Japan. So overall, if you look at, US is very popular for chip design in terms of IPs and chips. They own a lot of patents. Whatever the chips we use, more than 90%, the design happens in the United States. And US chip makers create all kinds of chips. And all these US chip makers, they have operations in various countries. But with respect to fabrication, it's only 10%. Whatever that's happening in the United States, it's very less. So US is very popular for fabless IPs, chip makers, and then EDA, electronic design automation. Also, it's popular for OSAT equipments. And UK is popular for fabless IP. Arm is there. Arm is very popular for their RISC processor. And Netherlands is popular for foundry equipment. And India is popular for design services. If anyone wants to deal with chip design, right, you might want to own the design. You are there to create the architecture. But when it comes to implementation, how you want to verify the chip, how you want to implement the chip, you can think of outsourcing the design to external vendor. So we have so many design services companies in India. Indian companies, they are very popular for design services. Similarly, Israel is also popular for fabless IP and design services. And China is very popular for product assembly. They work for OEMs like Apple, Dell, they make the final product. And there is some amount of fabrication happens, only 15%, primarily for the low technology nodes. And China is also popular for fabless IP, EDA, and testing. And Japan produces 17% of all chips. It's also popular for chip design. And basically, whatever the wafers we use, gases, lithography machines, all come from Japan. And Taiwan is very popular for fabrication. Taiwan produces 41% of all processor chips. And the most important thing is, more than 90% of the most advanced chips fabrication happens in Taiwan. And Korea produces 44% of all memory chips and 8% of all processor chips. It's also popular for chip design. Korea is also popular for fabrication, and it's very popular for memories. And similarly, Singapore is popular for fabless IP and chip maker. And Malaysia is very popular for OSATs. That's primarily for assembly and testing. Assembling, package, and testing the chips. This is how you can visualize the supply chain. Now, one thing I would like to share with you. If you consider the fabrication, mostly it happens in Taiwan. So, what's happening in the world is actually the entire world is looking at how to balance the supply chain. Instead of doing everything in one place, can we distribute it across various countries? That's why if you consider the governments, every government is looking at how to create fabrication units in their country. So, every government is allocating funds. US is going very aggressive and they want to have good manufacturing ecosystem in the United States. Similarly, India is also gearing up towards having good manufacturing ecosystem. All right.